Hello everyone. Today I will be talking more about data analysis for chemistry. So this video is actually the second video for this series. As in previous video we have discussed a lot about different ways how we can improve the quality of our data. For that, different types of uncertainty budgets and discussion about errors and other ways of reporting data have been discussed in first video. So here in this second video, today we will try to learn different concepts of mean, variance and standard deviation that are actually pertaining both to a large sample population, or you can also use them for a small sample. Moreover, we will also discuss more about relative standard deviation as a continuation from standard deviation, and I'll try to explain all of these concepts and how you can use these concepts in your daily basis experiments in your lab with different examples. So example for every different concepts will be presented in this talk, and at the end I will explain that how easily you can calculate all of these concepts depending upon your calculations from your data that you obtain by doing different experiments. So there are two ways I will be talking about. So the first will be how you can calculate by hand and how you can calculate by Excel using Microsoft Excel. So before going to more details and further explanation for all of these concepts, so first I just want to emphasize, why do we bother with means and standard deviation? So what is the importance of these? So because these two statistics tells us a great deal about the data and the population from which they come. So if I'm talking about mean, so it is actually can be calculated by repeated measurements from your experiments, and it is an estimate of the concentration of the test solution. For example, if you are checking the concentration of a solution, then here you can say that the mean will be the estimation of that concentration of test solution that you calculated after different repeated measurements, and the sample standard deviation. So an estimate that how much concentration of your solution is there, and the sample standard deviation will actually gives you how random is your data scattered around your mean value. So this randomness will actually help you to understand that how reliable and how repeatable is your data. So this is very important when you are particularly doing experiments that are related to analytical chemistry or some other experimental, or if you are doing some applications that are related to getting some data and then manipulating them, interpreting them to achieve certain values like Faradic efficiencies, like rate of certain reactions, or if you want to study kinetics of that reactions. So all of these informations, they are very important, but these information, they will not exactly tell you that how much is the concentration. So that is another question, and for that you have to develop different uncertainty budgets, and in those budgets you actually have to include different types of errors and random and systematic, and that are actually coming from your experiment. So the first important point that why we have to rely on these concepts is that we should understand that where our data is lying. So if our data is very much scattered, then we have to control the causes that are actually scattering our data. So like mainly there might be some errors, so they may be random, systematic or personal errors. Alright, so another important question regarding this topic is that why is it good to repeat analytical measurements? So why we are emphasizing a lot that students should do one experiment to get a result at least 3 to 5 times. So why it is very important? So the good thing is, and very simple answer is that repeated measurements will give you confidence about your result. So if your repetitions they are similar, you are getting same result every time, then your confidence regarding your data will be enhanced. So for getting better answer by repeating measurements, it's an important criteria for understanding the data analysis in chemistry. Alright, so now I will start first with mean. So what is mean and what's its definition and what is its importance in our chemistry calculations. Alright, so the sample mean is actually the arithmetic, is also called as arithmetic mean or average, and it's actually the result of all the results. So for example, if you are measuring a concentration of your solution and you are doing that measurement maybe 5 times, maybe 10 times or 20 times, so your mean will be the result of sum of all those different measurements, and then you will divide total number of measurements. So sum of all of your data divided by number of data. So this is actually called mean. It's very simple. So here in this figure you can see very clearly that if, for example, if the mean of your different measurements that are around 500, so if mean is around 10, so most of the data they is actually scattering above and below of your mean line. So this is very important. So some data they are actually in positive mean they have some value increasing from 10, and some data they have values less than 10. So why doing repeated measurements is helpful in this case particularly. So the data is symmetrically distributed about the mean, so we can say that the data that is on the high side will cancel the data on the low side. So at the end the mean of the data will give you a number that will be in between, and that number is actually statistically is very helpful to interpret your results that are actually for normally distributed data and for large populations. So this is good because the population mean is actually the true result in the absence of the systematic error. So for the means of the end data that are actually randomly drawn from normally distributed populations, maybe starting from 10 and then it's going to 500 measurements. So you can easily see that whether your repeatability of that experiment is within that range or not, or it's quite repeatable, or it has some error window. So how you can overcome that error window. So this sounds about right. As we know that data is symmetrically distributed about the mean, so we would expect that the results that are on the high side and the low side they will balance each other. And this is actually the good quality why we need different repeats for one measurement. So again, mean, it's simple arithmetic average of sum of all measurements divided by the total number of those measurements. Alright, so next is standard deviation and variance. So it's quite simple and it's related to mean. So here in standard deviation we can say the spread of population is actually shown by the flatness of the bell-shaped curve is measured by the standard deviation or its square, or if you are just using that standard deviation, and we can also use its square to more simplify it. So I will explain these equations. So in the first equation, S is equals to sum of all measurements, and that is actually relative to their standard deviation, and divided by the total number of data minus 1. So similarly, relative standard variation, relative standard deviations square is actually called variance. So that is S square, and you just have to take the square of that equation. So in standard deviation, that is actually explained by the first equation. We can say that the sample standard deviation is referred to the n number of measurements, and we are actually relating the standard deviation with a particular deviation, that how much deviance is there for your data. So how the sample standard deviation also converges on the population as the values of the n increases. So this is very important. So for example, in this figure you can see that sample standard deviation that is actually 1, and for after 500 measurements you can see that some data they are actually lying above and some data they are actually lying below this sample standard deviation line. So by this we can have an average estimation of our data, and we can check whether our repeatability is good or not. So this is actually again improving the reliability and the confidence in our data. Alright, so relative standard deviation, also known as the coefficient of variation, it's actually the standard deviation of a measurement expressed as a fraction. So expressing a fraction of standard deviation with the mean, and we are actually normally expressing it in the form of percentage. So relative standard deviation of any analytical result is actually often quoted as it gives an immediate impression of the precision of the measurement. So precision of the measurement is another important criteria. I have already discussed this in my previous video. So less than 1% is actually usually considered very good. So if you have a good data and it is precise, then the precision of that measurement should be less than 1%. Relative standard deviation should be 1%. So for routine measurement we are also using around 1 to 5% is a range that is actually acceptable. So standard deviation has the same unit as the mean, and variance has the units of the mean square. So as in previous slide I showed that the variance is actually the square of standard deviation. So relative standard deviation is actually the fraction, and so therefore it is unitless. So standard deviation and mean, they both have the same unit, so in this fraction you can easily cancel them, so it is actually unitless. So moving on to examples for all of these concepts that I have discussed in my previous slides. So first of all, I'm giving here an example where we have a gas chromatography experiment, and in gas chromatography experiment we need an internal standard. So for example, isopropanol is used to account the variability in the volume injected between tests. So for GC analysis, gas chromatography analysis, we need to inject different amount of volumes of our solutions or analyte. So here we have a 4-point calibration curve and the repeated analysis of the unknown samples. So total there are 4-point calibration curves, but the total number of samples or total number of measurements are actually 6. So we can say that 6 times samples injected into the gas GC. So after 6 times injection we got some peak area in arbitrary units. So these are the values that are enlisted here for 6 different measurements. So first concept, that is actually mean. So how can I calculate the mean of this measurement? So here you can see, first of all, I have summed up all of these measurements. So I have summed up all of these 6 different values and I have divided those with 6, sum of those measurements with 6. So the number here below 2915964 is actually the mean of all of these measurements. So whether this mean is good or bad, that's another discussion, and for that and for more explaining of the reliability of these measurements, we need standard deviations and we need relative standard deviations. So in standard deviation, as I discussed before, so it is actually the summation again, but relative to the mean data. So in previous slide the mean value is 2915964. So here in this we subtracted all of our measurements first with the mean. So how every measurement is actually deviating away from our mean value. So that's important. So that is actually giving you standard deviation. So the first thing is how reliable is your data can be easily analyzed, can be easily interpreted that how your standard deviation, how much is your standard deviation, and there must be a close range that should be very close to the mean. So for calculation of standard deviation, we will sum up all of the differences of every measurement with the mean of whole set of data divided by for n minus 1, that is 5. So total measurements was 6, but here we will divide by 5. So the standard deviation value is 52705. So similarly, by now we got standard deviation, we have mean, so we can get the fraction of those in percentage, and that is actually 18.03% relative standard deviation. So actually 18.03% is it depends on your analytical measurement, that what type or what sort of experiment you are doing. So in some experiments these are acceptable, but some experiments they are not. These values they are quite big, so it varies. So in previous two slides I have explained that how you can easily calculate mean, standard deviation and relative standard deviation by using simple formula. But nowadays everyone is using Microsoft Excel due to convenience. So how can you calculate these in Microsoft Excel? It's very simple. I've just added a few steps here in this slide that will help you that how easily you can calculate all of these. So all of you know that in Microsoft Excel there are a variety of formula that you can simply use, and you can calculate different sorts of statistical calculations. So all right, so here in first step we will input our data. For example, here in the list below I have enlisted my data from A2 to A7. So if I want to calculate the average of all of these measurements, then I will in 9 the row 9 I will write equal sign in the Excel, and then I will write average, and then with a small bracket I will select A2 colon A7. So A2 colon A7 means A2 to A7, all of these measurements, so they will be under this formula. So what is the formula? Formula is average. So average of all of these measurements will be easily calculated. So similarly for standard deviation, instead of average we will use STDEV, that is the formula for standard deviation in Excel. So the selection of column is same. So to calculate the relative standard deviation, so we have already calculated average and standard deviation, so we will divide both of these and we will multiply by 100 to get their fraction in percentage. That will give you relative standard deviation. Alright, at the end there's one important point that is actually called median. So median is actually the middle value of a set of data when arranged in ascending order. So it's very important. You have to arrange your data in ascending order, and then the middle value will be median. So now there are two possibilities. If you have odd number of data or if you have even number of data, so that's another case. If you have odd number of data, that's simple. The unique middle number, there will be just only one middle datum, that will be your median. And if you have even number, then you have to take the average of two middle numbers. So this is very important. And median, again, it is similar to mean, and it is giving you an estimation that how close is your data related to your average data. So it is robust because no matter how outrageous one or more extreme values, there must be one individual value at the end of the list. So you can easily see that so what is the average, proposed average in your data. You can easily look by choosing your middle value among your set of data. Alright friends, so this is the second video of this series, and I hope you will understand data analysis in chemistry. I will come up with more videos that will explain that how statistically you can improve your data measurement, reliability and repeatability. So what is the main idea and what is the bottom line to learn all of these important concepts? The main thing is that if you present some data, then there must be enhanced confidence in you that I am presenting my data, and my data is without errors, my data is statistically proven, my data is reliable, my data is repeatable with good accuracy, with good precision. So all of these qualities will enhance your all over results. I hope you will find this video very useful. I am waiting for your comments and suggestions. Thank you.